Okay, good morning everyone. Welcome to the PPT or Tech Talk of Java. Before introducing going to the PPT, let me introduce myself. Myself Bhuvneshwar. Currently myself Bhuvneshwar. Sorry for the interruption. Myself Bhuvneshwar uh, from the Department of Computer Science and Engineering from A section. You can see my roll number on the screen. Like this whole PPT is going to the about the topic embedded and real-time Java, and which belongs to the subject programming with the objects. Without any further delay, let me go into the topic. Yeah, yeah. Now let us see advantages of Java technology model. See, simplicity. First, it is simplicity. Easier language to learn than traditional. Like you can see now, Java is much more simpler to learn, as it is harder than Python or some. Excuse me. Yeah. Earlier language to learn the traditional C or C++ and still has object-oriented methodology. Yeah, if you see, even C is almost Java looks like the C, but the way the makes Java different from the C was it's object-oriented. Except that every syntax will be same, but it makes an add over advantage or Java for way more better than C or C++. Even though C++ is an object-oriented, but object-oriented concepts in Java were much more better than in C++. And next coming is security and safety. Java programs have more robust security checking with the RTE, creating a sandbox where applications can run safely. Lack of pointers eliminates direct memory access due to the as there are no pointers in Java, so we can't access the memory directly in Java. It's increased the security and safety in Java. Next, portability, robust and distribution. Applications can be easily developed on desktop systems and protected with minimal effort to target device. Write once, run everywhere mentality. Like Java, even a machine independent language. Write once and you can run it everywhere. Now, like let us discuss the uh, disadvantage of embedded Java. High huge speed disadvantages. Interpreted Java code is still 5 to 10 lines slower than the similar application. Improvements made to JVM technology have enhanced this over the years, often used on how the application is written, as well as Java program outperform a poorly written C program. For embedded applications to do really need to interrupt code, so can use native compiled code. And again, embedded yeah, yeah. Embedded Java technology still relatively new and industry support has been slow to catch on. Biggest disadvantage: lack of RTOS support to standard. Early embedded Java applications were very similar to conventional desktop programs, fine for some apps, but deadline control and interrupt handling are necessary. Great improvement in the game since 1988. Now, yeah, real-time specifications of Java guiding principles. Applicability to particular Java environment do not include specs that restrict use of particular Java environment. Backward capability. RTSJ shall not prevent existing and non-real-time Java programs from executing on implementations of the RTJS. Write once, run everywhere. Mentality should be follows such an operations. RTJ guiding principles. RTJ should address real-time system practical and allow the information of advanced features in the future. Predictable execution as first priority in all the trade-offs. May come at expense of general computing performance, but will allow for great real-time integration. No syntactic extensions. RTJ will not introduce new keywords or other systematic extensions to the Java language. Real-time specifications of Java. Finalized in November 2001, standard specifications of garbage, collection memory management and task thread control, addition classes and extension to standard Java JDK. However, no new syntax was necessary. Java real-time packages. Java real-time specifications provide modifications to, like, you can see that Java real-time specifications provide modification to Java language spec, like which was included in Java JDK, and even the JVM specs. JVM means Java virtual machines. Even there are many modifications to the Java virtual machines and Java language specifications. Like real-time specifications provide modification to the Java language spec and JVM spec. New API to enable the creation, verification, analysis, and execution and management of the real-time Java threads. Like new APIs in the JDK have enabled the creation, verification, analysis, and execution of management of real-time Java threads. New API in standard extension package javax.realtime. Even there is new APIs in standard extension packages in the javax. You can see in the javax.realtime. Yeah. Again Java. Sorry. Let me erase the screen. Yeah, as now we discussed, Java real-time package. Real-time instruction provides modifications of Java language specification JVM specs. New APIs to enable creation, verification, analysis, execution, and management of real-time Java threads. New API and standard extension package Java.realtime. Yeah. Now let us see seven areas of enhancement of embedded Java. Thread scheduling and dispatching. Like in here, scheduling and dispatching of thread has improved way more better. Like threads and scheduling and dispatching has improved. And again, the memory management. You can see here the memory management has a lot more improvements in here in this sector. And again, synchronization and resource sharing. See, you can see now synchronization and resource sharing. Synchronization and resource sharing has more developments here. Next, asynchronous transfer of asynchronous event handling. Even asynchronous, when compared to synchronization and resource sharing, asynchronous event handling had improved way more better. And next, asynchronous transfer of control. Even had from the Java to embedded Java. Next, physical memory access. Like it's physical memory access here has given the way like much more security here. Like you can get more security in here, like it won't give any direct access to the physical memory. Like you can't even there are no pointers. It's more added more security here. Now, for memory areas, speed memory. Object have lifetime defined by syntactic scope. Here, even here, the object have lifetime defined as, like with respect to the syntax, object will have its lifetime as if the syntax ends at its particular time, the object is going to be get distracted automatically from the program or garbagely collected from the program. Next, physical memory. Objects created within the specific physical memory physical memory. Objects created within specific physical memory regions having certain characteristics. Important memory. Objects create can't be destroyed once allowed. They stay until తీసుంటుందా ఉండదు అనుకుంటా ఉంటే గువా జ్యూస్ తీసుకుంటారా ఉంటే చూసి వస్తాను కదరా. Physical memory. Objects created in specific physical memory regions having certain characteristics. Immortal memory. Objects can't be destroyed once allocated. They stay until the end of application. Like immortal memory. Objects can't be destroyed once allocated. They stay until the end of application. Heap memory. Objects represent an area of memory on the heap. Now, asynchronous event. some internal or external event that happens. Not all real life events are predictable in time and frequency. System needs to respond to the changing environment. Ability of real time systems to react to the events requires reliable asynchronous technology, as we discussed. Some internal or external event that happens not on all real times are predictable in the time frequency. Systems need to be respond to the changing environment. Ability of real time systems to react to the events requires reliable asynchronous technicians. Most platforms supported. Yeah, operating systems. Windows CE and Linux supports Java embedded. Like I think most of the operating OS will support Java embedded processors. Pico Java, Sun Java processor, strong ARM, MIPs, even every Intel process, MIP ARM process, and every processor which was developed by Sun Microsystems. Yeah, here we will discuss Java embedded Linux. Java does IO by input output. IO means input output operations by opening files which are the Linux device drivers. Example, device and memory. Java can seek an addition to read, write, and open. Bootstrapping allows Linux to load necessary drivers and networking files and start running the Java. Standard Linux distribution with networking supported requires lots of memory. Like standard Linux distribution with networking supports lots of memory. You can see here. Improving performance. Java bytecode programs are typically 10 lines slower than the programs written in almost Java bytecode. Even Java was built based on C, right? Java is even as it is a high level language, it is 10 times slower than the C or C++. It's 10 times slower than the C or C++. How well the program is written is more important as well. Java programs can equal the efficiency of average written C or C program. Interrupt codes uses the less program. Interrupting the codes use less ROM. Interrupt codes use less ROM in Java. Here, compilation into native code. AOT, ahead of time. JIT, just in time. Dynamic. These are going to compilation into native time. AOT, which you consider ahead of time. And JIT stands for just in time. As you can see, just in time means at a given specific time if it's perform the operation, then we going to convert them just in time. Next is dynamic compilation. This is the next which we consider the dynamic compilation. Yeah, next let us briefly discuss the 3 points. What does AOT compilation means? AOT compilation is similar to the C compilers, tends to create larger executable. It almost similar to the, we can almost compare it with the C compilers, how the C compilers are executed. Tends to create large executables, need to recompile for different platforms, or when loading a different class. Need to recompile for different platforms or when loading a different class. Can compile everything including class libraries. It can compile everything include class libraries excuse me. You can compile everything including the class, even the class. You can compile the class libraries with AOT compilation. Next, JIT compilation. Here in JIT compilation, JIT compilation is mission dependent, higher startup cost, not ideal for embedded systems, requires faster CPU, lots of virtual memory, and fast disk drive for paging. Like it's a JIT compilation is mission independent. Like it won't vary for mission and mission. Like it's for every mission it will be the same. JIT compilation will be same for every mission. Even you consider any operating system or any different, whether it is a personal or any computer or any system or any operating system, JIT compilation will be the same. Higher startup cost. The startup cost for JIT compilation will be somewhat way more high than the AOT compilation. Not ideal for embedded systems. It won't be any ideal for embedded systems. Requires faster CPU. To access JIT compilation, we requires a fast CPU. When it compared to slower CPU, it may take more time and it can't give appropriate results. So you may require the faster CPU for this, and lots of virtual memory. And you require lots of virtual memory for JIT compilation. Like, yeah, as we can see, we had virtual memory in the JVM. Same like we should require virtual memory for the JIT compilation and fast disk drive for paging. Now let us discuss what does the dynamic compilation mean. Dynamic compiles code that is being more frequently used more, like dynamically compiles code that is being more, it's compile first which is more frequently used. Typically uses JIT compilers. Even it was based on JIT compilers, don't require virtual memory. But the difference between JIT compilation and dynamic compilation is JIT compilers requires virtual memory, whereas dynamic compilation does not require virtual memory and adaptable to available system memory. It's guaranteed to meet timing constants such that applications can change the compiler's thread priority for greater predictability. Like, it's guaranteed to meet timing constant application for change the productivity. Now let us see other methods to improve performance. Like, how can we improve performance of Java? Let us see some more points. Static linking. Place bytecode in ROM. If you place the bytecode in directly in ROM, you can increase the performance. Next, rewrite the bytecode. Even if you rewrite bytecode interpret in assembly language, you can even use a Java chip. You can increase the performance even here. These are the whole topics still we discuss, and let us see the conclusion of the topic. Recent conclusion. Recent advances in embedded. Let me change the pen. Yeah, recent recent advancements in technology and advances. Oh fuck. Yeah, recent advancement in technology and advances of artists are allowed real-time capabilities and personalities in Java world. Many current embedded Java systems are non-real-time or a limited subset of RTSJ principles. Some environments and broad range of distributions environment make embedded Java programming much simpler and more robust. Like, these are going to be more key features of the. These are the conclusion summaries which we discussed till in the whole PPT. Let us quickly recall what we have discussed till now. Yeah, at starting, yeah, as we started here from the advantages of technology, as we discussed the advantages of the Java technology model, and next we discussed the disadvantages of embedded Java, and again we discussed some more disadvantages of the embedded Java. Then we moved into real-time specifications for Java guiding principles, accessibility to particular Java environments. Like, we have discussed many points here. Next, we discussed the RTSJ guiding principles. And next, we discussed real-time specifications of Java. And next, we discussed the JavaX.realtime package, like package in this. And next we saw the 7 areas of enhancement, like does it develop and where improved. And next we discuss the 4 memory areas. And next next we discuss the asynchronous events. And next we discuss major platforms supported for it. As we see, what are the major platforms support for this Java, and we said many. And at last we discuss the Java embedded Linux. And at last we started the discuss the improving performance and compilation into native code. And later we discuss the difference of different types of AOT compilation, JIT compilation, dynamic compilation. We saw this difference between these three. AOT compilation difference, what make the difference between AOT compilation, JIT compilation and dynamic compilation. And next we saw the other methods to improve performance. Like, how can we improve the performance by static linking, rewriting bytecode, and many other. Yeah, these are the whole we discussed in the whole PPT. And last we discussed the conclusions and summaries. I given I give an overall view in the conclusion summaries in the whole topic discussed here. Thank you. This is the whole PPT. I hope I discussed each and every point clear and you understood everything. Thank you.